Yeah, hello everyone. So this is a question from JEE Mains 2026 28 Jan evening, and consider the following aqueous solutions. Okay, so important detail for us that the solvent is water. I mean, this is a solution in which involves solutions, so therefore it's important to know what is the solute and what is the solvent. So that's why I have written it down. 2.2 gram glucose in 125 ml of solution. Okay, 1.9 gram calcium chloride in 250 ml of solution. Okay, 9 gram urea in 500 ml of solution. Cool. 20.5 gram aluminum sulfate in 750 ml of solution. Okay, the correct increasing order, okay, correct increasing order of boiling point of these solutions will be, okay, so we have to talk about boiling point. Okay, so before we discuss in detail, we should know what is the meaning of boiling point. Okay, so boiling point, we should remember that it is the temperature at which vapor pressure of liquid is equal to the atmospheric pressure. So at whatever temperature this happens, that temperature is known as our boiling point. Okay, the second important thing for this question is we need to know that boiling point of solution is always greater than the boiling point of the pure solvent. Okay, so these are the two things that we need to know, and this increase of boiling point of solution compared to the boiling point of pure solvent is known as elevation in boiling point. This increase, we can see solution boiling point more than the pure solvent, so that increase is known as elevation in boiling point. Okay, cool. So if we draw a graph of vapor pressure versus temperature, we'll see that roughly we get something like this. Okay, where the solvent, this is the curve for solvent and this is the curve for solution. As you can see, this is a graph of vapor pressure versus temperature. Okay, and let us say that this value here is 1 atmosphere, that is the atmospheric pressure. So if we draw a horizontal line to intersect these curves, this particular temperature is the temperature at which the solvent will boil, because you can see at this particular temperature the vapor pressure of liquid is equal to 1 atmosphere. So this is the boiling point of liquid. So let us say that boiling point is TB naught. Similarly, we can see that this will be the boiling point of the solution, because at this point you can clearly see the vapor pressure curve. You can clearly see the vapor pressure is equal to the atmospheric pressure at this particular temperature. So let us say that temperature is TB. Okay, so as we have stated the fact that boiling point of solution always greater than boiling point of pure solvent, you can see in the x-axis TB is higher than TB naught. Okay, so this difference, okay, this particular difference, which is TB minus TB naught, that is known as delta TB, and delta TB is also called the elevation of boiling point. And delta TB, when we take into consideration the association and dissociation, so the formula, so actually delta TB for a non-electrolyte, so delta TB for a non-electrolyte is Kb into m. But there are certain solutes which can undergo association or dissociation, so therefore for them delta TB, so we can modify the formula to I into Kb into m, where I is the Van 't Hoff factor. Van 't Hoff factor, and whenever there is dissociation, because in this question there is only dissociation, so in case of dissociation, I is total number of ions produced from 1 molecule of solute. Okay, so we will talk in detail about how to calculate I for every solute. Okay, so Vent Hoff factor, and in case of dissociation it is the total number of ions produced from one molecule of the solute. Cool. Then we have Kb. Kb is the molal elevation constant. And it is the molal elevation constant of the solvent, which is very important. And for water, its value is 0.52. Okay, and M is the molality. Okay, M is the molality of the solution. Yeah, and as we know that non-electrolytes, for example sugar, urea, these guys, they don't undergo any dissociation or association in solution. So for non-electrolytes, I value is always equal to 1 because they don't associate, neither dissociate. Okay, one more thing that we need to know before we go and see the each and every option and calculate. If you have a very dilute solution, okay, in which the amount of solute is very less compared to the solvent, molarity is approximately equal to, or mathematical terms it is equal to the molality. Okay, because the amount of solute present is very less, so therefore the total volume of solution can be technically considered to be the volume of solvent, because the amount of solute is very less there. And also here I forgot one important point: very dilute solution, very dilute aqueous solution. Be careful, this should be aqueous, because density plays an important role in making both of them equal. So we know that density is of water is 1 gram per centimeter cube, or 1 kg per meter cube. So you can clearly see that since the density is 1 gram per centimeter cube, we can say that 1 liter of water, so 1 liter of water has mass of 1 kg. So magnitude wise, the volume of the solution and the mass of the solution are equal. And we know that molarity is number of moles of solute by volume of the solution, that is 1 liter, and molality is again number of moles of solute divided by mass of the solvent. So since the amount of solute considered is very less, so this is also going to be 1 kg. So therefore numerically molarity and molality comes out to be same. So you will understand why I am discussing this fact here. Okay, so now coming back to the original equation, that is, we know that delta TB is equal to I into KB into M. Okay, in the question, okay, let's go back to the question. So they are asking us to arrange them in a correct increasing order of boiling point of these solutions. Okay, boiling point of solution. Okay, so we know that delta TB is I into KB into M, and we also know that delta TB can be written as TB minus TB naught is equal to I into KB into M, where TB is the boiling point of solution, TB naught is the boiling point of solvent, and solvent in each case is water, so this is going to be 100 degrees Celsius, or you can consider it to be a constant. So TB is equal to I into KB into M plus TB naught. This is a constant for each and every case if the solvent is water. Okay, so we can clearly see TB is technically depending upon I into KB into M, or we can say TB is directly proportional to I into KB into M. One more thing is this guy KB is molal elevation constant, and it also depends upon the solvent, and in all 4 cases we have used water as the solvent, so therefore this is again going to be constant. Okay, so we can say that TB is basically directly proportional to I into small m. And just now we said that if you have a very dilute solution, molarity and molality are equal, so therefore we can say that TB is directly proportional to the product of I into capital M. Okay, So we have to calculate what is TB. TB is the boiling point of solution, and we have to calculate I into M for all the four options. Okay, so the first one is talking about glucose. Glucose is a non-electrolyte, remember, does not associate or dissociate. So therefore I value is going to be 1. So TB is directly proportional to 1 into molarity of the solution. So number of moles of solute 2.2, mass given 180 is the molar mass of glucose into 1000, and volume of the solution is 125. So when we do this calculation, we get this value as 0.097. Second option is CaCl2. Okay, to calculate the I for CaCl2, so we know that CaCl2 decomposes into Ca plus 2 and 2 Cl minus. So there are how many total ions? 1 Ca plus 2 and 2 Cl minus. So there are total 3 ions. So therefore the value of I is equal to 3. And so therefore TB will be directly proportional to I is 3 into molarity. Molarity will be, given mass of CaCl2 is 1.9 divided by molar mass of CaCl2 is 111 into 1000 divided by volume of the solution is 250. So when we do this calculation, this comes out to be approximately 0.205. Third case is urea. Urea is again, the formula is NH2CONH2, and this guy is again a non-electrolyte. So therefore I value is going to be 1, and TB in that case will be directly proportional to 1 into the mass we have taken is 9, molar mass is 60 for urea, and into 1000 divided by we have taken 500 ml. So when we calculate this, we get that it is around 0.3 approximately. And the fourth one is aluminium sulfate, that is Al2SO4 3. We know that this guy decomposes into 2Al plus 3 plus 3SO4 minus 2. So therefore there are total 2Al plus 3 and 3 sulfate ions. So therefore I value is going to be 5. Okay, so TB will be directly proportional to 5 into molarity. Given mass is 20.5 divided by molar mass of aluminium sulfate is 342 into 1000 by volume of the solution given to us is 750. So this approximately comes out to be 0.4. So as you can see, maximum value is for the fourth option. So therefore 4 is the maximum increasing order. Since we have to arrange them in increasing order, so we'll start from the least one. So 1 has the least. Then we have 2 because it is 0.205. Then we have 3, because that's 0.3. And finally we have 4, that is 0.4. So this is the order. Okay, thank you.